Woohoo! Welcome back. Today we're going to be working on factoring expressions with rational, and here I mean specifically fractional, exponents. And this may be a brand new topic for some folks, so I wanted to do a little bit of an introduction. So in order to get started, I wanted to talk about what x to the 5 halves really means. Now, you hopefully do know that this can be written as radical x to the 5th, and it can also be written as radical x to the 5th, as long as x is representing a non-negative number. So we're going to go ahead and assume for all this that we're not going to run into issues where we've got a square root of a negative number, we don't know what to do. So we don't worry about that right now. What we're going to focus on is the mechanics of what to do with this. So x to the 5 halves equals all these things, but also it equals this. X to the 5 halves is equal to x to the 1 half times x to the 4 halves. Now, what the heck does that even mean? Do you see why that's true? So if I have x to the 1 half times x to the 4 halves, remember the rule, when you multiply and you've got two expressions that have matching bases, so both have x as a base, then what do you do with the exponents? You add them. So in the same way, you can subtract when you're factoring out. So if I start with x to the 5 halves, I can split it up into 1 half and 4 halves. Does that make sense? So I can effectively factor out a radical. So in other words, this looks like radical x times x squared. So let's take a moment here and think about this. Now, unfortunately, this is a video setting, and so you can't ask me questions. But just to this point, even if we don't go any further, if you have any questions, go ahead and pause the video. Send me a message via the Canvas inbox or Pronto, or set up an appointment to go see the tutors, or if there are any online hours, go talk to them online and get a little bit of practice with this, because if you're a little rusty with what happens when you've got fractions as exponents, then what we're going to do going forward is going to be a little bit intense. So I'm going to go ahead, but again, no shame if you need to pause the video, go get some, get me to explain some things. We can practice lots of stuff. If we're in class, you could be asking me questions and we can be going over examples. So I'm going to go ahead and continue with the assumption that you've had a chance to do that. And now let's go on and talk about what the heck does this mean? Well, basically in this case, what we're trying to do, if you're asked to factor this, you're being asked to figure out what's common. And just to begin with, we see that there are a's that are common, so we can factor out some a's. But the thing is, these are not just factors that are just a. These are fractionals, so what we're actually dealing with is radicals. So the square root of a is what we're trying to factor out. And if we wrote it out in square roots, it would make more sense. So that's what I'm actually going to do first. So let me just say, a to the 1 half is radical a. So far, so good. A to the 3 halves is, and again, as long as radical a is well-defined in whatever system you're using, so as long as we're not having trouble with the domain. So in other words, we're not having a square root of negative number that we don't know how to handle. We can, so if a is 0 or positive, we've got radical a cubed, or we've got radical a cubed, right? We can look at it either way, as long as a is 0 or positive. And so what that means is if I look at this one, that actually means that I've got radical a, radical a, radical a. So that's how I'm going to write it. Okay, so over here, I'm going to rewrite this as radical a minus 3, and then I've got a to the 3 halves, which is basically 3 of those guys. Radical a, radical a, radical a. Okay, so then if you were shown this, what is common? Well, this one is pretty straightforward, right? I've got this guy. You don't even have to know what it's called to know that there's another matching one there. We could factor those out, right? So I factor out that radical a, or if you prefer square root of a. That's a little bit less precise because square root doesn't tell you whether it's the principal square root or the negative square root. So it's commonly used, but it's more like slang. Radical specifically tells you you're dealing with this one. And as I factor it out, I've got 1 minus 3, and then I got 2 more of these guys left. So far, so good? Okay, so this is radical a times 1 minus 3, and then what happens when I've got 2 of these? Square root of a times the square root of a, that's an a. And there we go. Now, what is the downside of doing this? Well, the downside of doing this is a lot of writing. And the problem was given to us in terms of exponents. So switching is like changing the language. So the last step should be to rewrite it back in the same language in which the problem was posed. Whenever possible, always do that. So if you start with fractions, end with fractions. If you start with radicals, end with radicals. But there's another problem, and that is this is a lot of work. So what I want to suggest, using the stuff that we did up there, let me suggest another possible solution. So if I've got a to the 1/2 minus 3a to the 3 halves, I'm going to think of it as a to the 1/2 minus 3a, and then I'm going to think of 3 halves as being 1/2 plus 2 halves. Now, why did I pick 1/2? Well, because that's what matches here, the 1/2 there and the 1/2 there. Okay, so then let me factor that out. A to the 1/2. That leaves 1 here, minus 3. Now I'm going to pull out a to the 1/2, so I'm left with the a to the 2 halves. And that's equal to a to the 1/2 times 1 minus 3a. And that's just 1, so I'm done. Now, honestly, I don't know that I can make the case that this is faster, especially if you feel more comfortable with radicals rather than exponents. However, what I'm going to say is the particular class that I'm teaching this in, Math 90, regardless of what class you're watching it for, the class that I'm teaching is a class which is intended for folks who want to go further in math. And the further you go in math, the more this form is going to be really important. And so practicing with this, doing the ugly grunt work of really, the hard work. So this is some of that, I guess, the shadow work in math, if you prefer. This is the hard work. These are those, lunges that no one wants to do, but, you end up with stronger legs because of them. Same thing. I would really encourage you to focus on this method, but you can always go back to looking at it in a more graphic setting. So if this is helpful and this is the way you can get through it, honestly, this is a very much a get it done situation. If this is what works for you, use it. But again, I encourage you to practice with this as much as you can because it'll just help you in the long run. Also, if this is like, I don't understand it at all, talk to a tutor, talk to me, show them this, show me this, say, I have no idea what's going on here, can we practice? And I or the tutors would be happy to. Okay, let's do a second problem. Okay, deep breath, you can do it. Factor Tree believes in you. I believe in you. You guys are awesome. And there's nothing there. Yay, we're done. No, sorry, that was a terrible joke. No, you ready? Okay, deep breath. Think about puppies. Think about happy things. You can do it. Oh no, it's okay. You can do it. I've got x minus 1 to the 1/2 minus x minus 1 to the negative 1/2. Okay, so note, what is this actually saying? This is actually saying I've got radical x minus 1 on top, and I'm subtracting radical x minus 1 in the denominator, which we aren't actually going to try to combine these. That is one possibility, but keep in mind this is a factoring situation. So we want to factor out the common factors rather than try to combine the expressions into one mega expression. Although that would be pretty cool. That would be a great monster movie. Mega expression versus Sharktopus. Here, Sharktopus is on board with this. That would be so cool. The Sharktopus here to see mega expression. So what I actually want to encourage you to do is to work with this. Okay, and I'm going to show you what I mean. We'll take lots of deep breaths and perhaps, talk about maybe getting extra help, talking with me during office hours, really making sure this makes sense, because this is kind of some manipulation that has to do with numbers that is possibly something you haven't really practiced yet. But again, setting a really good foundation for things that are going to come up in the future. Okay, so the first thing I'm going to identify is the smaller exponent. It's not always the first one. So I'm not going to try to factor this one. I'm going to try to factor this one. So I'm going to make a note. This is the smaller exponent. Okay. So that means, in fact, let me write this equal a little bit further down because I got a little excited and didn't give myself enough space. Pardon me. Okay. So I'm going to try to factor out an x minus 1 to the negative 1/2. And I know that when I factor out the second one, it's just going to be a 1, right? Because that's the whole thing right there. So I've got a minus 1 there, and I don't know what's there. So at least this is the beginning, right? So I know that I'm going to factor it out of the second expression, the second piece, that second term, I'm going to factor out completely. So whenever you factor something out completely, you leave a 1, just as a placeholder, effectively. Now, what is here? That is a very good question. So we have to kind of think backwards. So one way to think about it is, and you may not remember this, but when you were learning about the greatest common factor, when you were learning out factoring out the GCF, what we frequently did was, rather than do the factoring out part, we wrote out the multiplication and thought about, okay, what needs to be here? So when I take this, I multiply it times this, and I get this guy. So I know at the very least this first term is going to be an x minus 1 to some exponent, right? Oops, that was exciting. Oh my goodness, I should have stock in these guys. Oh no! Oh, even the whiteout doesn't want to do this problem. La la la. So it's lovely weather we're having, eh? Maybe. Okay, here we go. Let me try. That looks very professional. Yes, I do this for a living. Okay, here we go. So we're getting closer. This looks beautiful, right? We're almost there. So the question is, when I multiply this times this, I need to get to here. So what am I considering? X minus 1 to the 1/2 is equal to x minus 1 to the negative 1/2 plus what? Right? So if I'm going to break the exponent up, I break it up by adding, right? Just like this. We thought when I had x to the 5 halves, we thought 1/2 plus what? 1/2 plus 4 halves gives me 5 halves. So I'm thinking if I have x to the 1/2, I'm going to factor out a negative 1/2. That's what I'm factoring out, that I have to figure out what's left over. And I think, how do I get from negative 1/2 to 1/2? And the answer is I have to add 2 halves. Does that make sense? Negative 1/2 plus 2 halves equals negative 1 plus 2 over 2, which is 1/2. Right? So when I'm factoring out 1/2, I'm actually subtracting, or sorry, negative 1/2. When I'm factoring out a negative 1/2, I'm subtracting negative 1/2. So I end up with x minus 1 to the negative 1/2 times the quantity x minus 1 to the 2 halves minus 1. Now let's look at it from the multiplication perspective. When I multiply these two together, same base, so I add the exponents. Negative 1/2 plus 2 halves gives me 1/2, which is where I started, right? Second term, x minus 1 to the negative 1/2 times the negative 1. Well, if whenever you multiply something times 1 or negative 1, it just sits there, just like itself. So believe it or not, that's it. Okay. Now, even though there's no one in the audience, I am sensing that we could use another example. So, in the worst possible idea I might ever have had, I'm going to try to come up with a brand new problem just out of my head. Let's just try it out. And I'm going to go back to something simple. I'm going to go back to the letter x, and I'm going to say x to the negative 3 halves plus 4x to the 1/2. Let's just do that. Okay, so let's factor this guy. So first thing, which one's smaller? Well, this one's easy because the negative is always going to be smaller than a positive, so this is smaller. When we talk about smaller, I know you're looking at, some people will look at that and go, wait, that's 3 halves. 3 halves is bigger than 1/2. But when we talk about smaller, we mean further to the left. So a negative number is always smaller than a positive number, believe it or not. Even though its magnitude, its absolute value, may be different. When we ask smaller, we mean if it's negative, then it's smaller. Okay, so I'm going to factor out x to the negative 3 halves. So when I factor out x to the negative 3 halves, I'm going to end up with the first one I just factored out completely. Okay, then there's a plus, then there's a 4, right, because there's a 4 there, and there's x to some exponent. We don't know what, right, and that's what this becomes. And so what we're going to think is we're going to think, okay, if I have x to the 1/2, I want to know how I get to that from negative 3 halves. So if I have the x to the 1/2 that's there that we started with, and I want to factor out an x to the negative 3 halves, basically what I'm trying to do is I'm trying to figure out what was there. So in other words, I'm going to take a negative 3, wait, where was it? I'm going to take 1/2, the number, let me find some colors. I've got a green one. I want to find blue. Blue is very calming. And purple. There we go. So we're going to start with this number. And then I subtract the thing I want to factor out. Okay, so that's equal to 1/2 minus a negative plus 3/2 is equal to 4/2. So x to the 1/2 equals x to the negative 3/2 plus 4/2. Does that make sense? So we're pulling out the negative 3/2. So this is just the thought process right here. This is the work. So then I've got x to the negative 3/2 times 1 to get the original, right? Just that plain old guy, plus 4. And then I get this new exponent 4/2. And we can check by thinking through the multiplication, right? X to the negative 3/2 times 1 gives me x to the negative 3/2 plus 4, okay, plus 4. And then when I multiply these two, when you multiply the same base, you add the bases. Negative 3/2 times 4/2 gives us the 1/2 that we need. But 4/2 is just 2. Okay. And believe it or not, and I can actually feel that some people are throwing things at their screen right now, and I'm really with you. This is possibly a brand new topic, and this is possibly something that is maybe frustrating you really a lot. So what I would say is take a deep breath, take a break. You guys are amazing. You are so very smart, and I am so proud of you. This math class, this is an indication that you want to go on. You're challenging yourself to do what's going to end up being, some math you haven't seen before, probably some math that's going to frustrate you, and you're still willing to do it. And I am so proud of you for doing that. I really am. There's no shame. This is complicated. I'm not going to lie. The good news is that this is among the most complicated stuff we're going to do. So of course we do it in the first week, right? Haha, why wouldn't we do it in the first week of class? But the thing is this is a very small piece of what's happening in this class. A very, very small piece. It would be awesome if it makes sense, but if it doesn't right now, that's okay. That's okay. Get help, work together, work through the homework, do your best. I am happy to help you with it. Tutors will be thrilled to help you with it. Some of them are going to say, yeah, this is really as hard as you think it is. And it's likely that some of the tutors, even me sometimes when I'm trying to do these, I'll be a little bit stuck. I'll be like, wait, how do you do this again? So be gentle with yourself. Make sure you take a break, get hydrated, get a snack, go listen to some music, dance, pet a dog, go look at something green, even take a nap, and then come back to it. Try it again, give yourself a couple chances because sometimes brains take a couple times. So if you can watch this video a couple times, if any of you are the Teletubbies generation, you remember they showed all those videos twice for a reason, because people work better with repetition. So come back to this video at another time when you're nice and mellow and, or excited for a challenge, and then be very gentle with yourself because this is not easy. And it, again, very small piece of this class. So thank you for making it to the end of this video. I think you're awesome. It really will be okay. There'll be times when you feel this frustrated, and for those of you you're looking at this going, this is great, I understand it, then awesome, wonderful, woohoo. So and if you don't, it's really okay. It's really, really okay. We will get through it. We will work together. So okay, I'm gonna say woohoo, you're awesome. Remember, even when you get frustrated, take a break and then math on. Woohoo!